Welcome to this video. Today I will present you the project I developed in the course Microcontroller Technik in Aachen. My name is Elena Kremers and the project is called Train Your Perfect Pitch. With this project you can train your musical ear to get a perfect pitch. Before showing the implementation, I'd like to present you the functions of my project and how it looks.
As you can see, for this project I used the microcontroller, the educational booster pack and the audio booster pack. The advantage of the audio booster pack is that we have a lever to adjust the volume, and also if we want to practice, for example in the train where nobody else should hear the sounds, we can connect headphones without changing anything in the program code. It will just work automatically. When the user first starts the program, he sees an instruction which tells how to use the application. It says that you will see a note, and by moving the joystick up or down you have to hit the note. When moving the joystick down while you are seeing the instruction, it will lead you to the next page. This page explains you how to use the buttons. By pressing S2, you hear the current note you adjusted with the joystick. By pressing the joystick, you hear the first note from which you start. And by pressing S1, you can lock in the current note, and the LED will give you feedback how good your guess is. On the next page, the user will see what the colors of the LED means. It says a red LED means you are far away from the target. If the LED is blue, you are within 1 octave, and if the LED is green, that's perfect because then you hit the note, and after 1 second it will show you the next note. Let's move the joystick 1 down again. Now it says press 1 to start the game. So let's do it. The first level shows us an F4, so we have to move the joystick up or down to hit F4. Let's first hear the current note. Now I can think this note could be, and I know the A4, which is a note musicians use to tune their instruments. And from what I heard, I think the current note is above F4. And we can already, if we like, check how far it is above. By pressing S1, we now see a red LED. So we know it's not within 1 octave. So let's go down a few notes. By moving the joystick once down, we will change the note by 1/2 note. So from the F we would go down to E and up to F sharp, for example. So for 1 octave in this case means also 12 notes. So we went down a bit. Let's check the current note. It is lower than the first note, and we can check the first note by pressing this button. And when we press both buttons right after each other, like this, we can try to get the interval we went down. That could also be a clue how close we are to the F4. Now, I think it's not completely the F4, but let's check how close we are. It's blue, so we are within 1 octave. But let's go down a little bit more. So now I adjusted it a bit and I ended up with this note. And I think that could be F4, so let's log it in. It is green, so perfect, it was F4. And now let's go on for the next level, the A4. At first we can hear again the first note, which I think is higher, but could be in the same octave. Let's check it. It is blue, so it's in the same octave. Let's go down a little bit. Now to show you that it is exactly the note and not a bit below or above, I will place my tuner next to the microcontroller and play the note again. And the tuner says it's an A, and as you can see also it's exactly 440 Hz. So let's log in if the microcontroller also says it's an A4. It is. So we can continue with the next level, but of course without the tuner, because we don't want to cheat. You can now continue with this level and do as many levels as you like. Now let's have a look at the implementation. We have two classes, the controller and the UI handler. In the UI handler we have private properties for the buttons, the LED and the display, and also for the audio output and the controller. And we also save here the instruction texts. At the functions we will have a look in the implementation. The UI handler has a constructor to set up the buttons, the LED and the joystick. We also enable the output, and after setting up everything we display the first instruction. In the constructor we also check if the joystick is moved up or down to change the instruction page or increase and decrease a note, and we also check the other buttons. To play a note we fill a table with Zenus values. In this Zenus values we give in a FIFO queue to the output, which will then play the values. And in this if condition we check if the S2 button or the joystick button is not pressed anymore. To show the feedback LED we give the function an integer between 0 and 2. 2 means the user is completely wrong, so we will show the red LED and switch off the others. And 0 means the user is correct, so we will switch on the green LED and switch off the others and then wait 1 second before we start a new round. When starting a new round we first switch off all LEDs, then we get a new node from the controller, clear the screen and display this new node. To display the instruction we also clear the screen, set the font and the font color, and then depending on which page the controller saved we will display the string for the instruction. Now let's have a look at the controller. Here we also have some private properties. The first one is a start node, which is the node the user will hear when pressing the joystick button. The current node, which is the node the user will hear when pressing S2. And the target node, which is the node that is displayed. In the controller we also save which instruction page is displayed at the moment. And here we also have some functions, but let's have a look at the functions in the implementation. We have two functions to convert an integer between 1 and 88 as a node. The first one gets an integer between 1 and 12 and gives us the name of the node between C and H. It's H because I used the German names, otherwise it would be B. We also need the octave, and this one we get in the function node as string. At first we will get the name from the other function, and then we will check the octave by subtracting 3 from the node and divide it by 13. This works for all the octaves apart from the lowest 3 node. There we have just to hardcode the 0 as an octave. When starting a new round we create 2 random numbers. The first one is the start node the user starts with, and the other is the target node. The target node we will return as a constant char pointer to show it on the display. When the user moves the joystick up or down we have to increase or decrease the node. And to get the feedback when checking the node we check if the difference is above 12, then we return 2 because it's completely wrong. If it is above 0 but below 12, we will return 1, and otherwise the current node and the target node are the same, and then it's correct and we return 0. When the instruction is displayed and the user moves the joystick up and down, you could see that the next instruction page is displayed, or the previous one, and for this I implemented two functions, next instruction and previous instruction, which will just add one to the instruction page or subtract one, but only if it's not the first or the last page. And for the instruction page we also have a getter. There are some improvements that can be done. For example, the nodes which are displayed are not completely random at the moment. If the user restarts the microcontroller, he will see the node F4 again, and then after it again A4, so he can only repeat the levels but don't have really random nodes. Another option we can add is limiting the amount of tries with, for example, lives. So we can add a graphic at the right corner which shows lives, and every time the user is completely wrong we can remove one life. And then we can also add a counter to count how many levels the user completed before losing all lives. And then there are also other options. For example, the user can just choose nodes in a certain range, for example between octave 2 and 4, because that's the nodes maybe the user needs the most. And we can also then maybe change in which range the blue LED is displayed, for example if it is an octave or just within 5 nodes correct. So there are a lot of options to extend the project. Thanks for your attention and watching my video. If you like, you can also check out the other videos on this channel.